Today I'm going to go over photosynthesis, which includes two phases, the light reaction and the dark reaction, also known as the Calvin cycle. Starting the light reaction, H2O here is split, offering an electron. When H2O is split, this releases oxygen and 2 molecules of hydrogen. The electron moves into photosystem 2, and light hits the photosystem, charging this electron. Now, when the electron's been charged up enough, it's going to move its way up here, and is then going to be pumped through protein pumps down to photosystem 1. Now, at this point right here, the electron has lost energy, so therefore it needs to be recharged, and light is going to enter photosystem 1 and recharge the electron just as it did in photosystem 2. Then it's going to be pumped through the protein pumps, and the electron is passed through and the protein pumps, which creates a concentration gradient in the thylakoid. Now, this concentration gradient powers ATP synthase, which phosphorylates ADP to ATP. And electrons are then used to reduce NADP plus to NADPH. Now, when enough ATP and NADPH are being made, those are then going to be used to fuel the Calvin cycle, or the dark reaction. To start the Calvin cycle, carbon is attached to ribulose bisphosphate, which is a 6-carbon molecule. 2 phosphates on the end. The ribulose bisphosphate at the starting point, which is the first cycle, or the first phase, is broken up into three steps or 3 stages, whatever you'd like to say. Carbon fixation. Now, this molecule is broken down into 2 3-carbon molecules known as PGA. Alright. Known as PGA. Okay. The Calvin cycle has 3 steps, as I say, carbon fixation, reduction, and regeneration. The next step, known as the reduction stage, begins with 2 molecules of ATP and NADPH, reducing the 2 3-carbon molecules to glyceraldehyde 3-phosphate. So, at this point right here, this is going to be our reduction stage. Alright, so here's our 2 ATP and our 2 NADPH that we just got from our photosynthesis cycle. Light reaction. Alright. 2 ADP, 2 NADP plus. Okay. Those are used. So then from when you go into here, when the ATP and the NADPH are used up, this creates 2 molecules of glyceraldehyde 3-phosphate. For short, call it G3P. Alright. Now, once we move through here, from glyceraldehyde 3-phosphate, the cycle runs enough times until it has 6 molecules of G3P. So we already had 2 molecules right now of just it going one time, so we'd have to go 2 more. to make 6 molecules. So once it reaches that, it'll go to 6 molecules of glyceraldehyde 3-phosphate. One molecule is going to come down here. It's going to break off of the G3P, 6G3P. This one's going to come up here. Well, the remaining glyceraldehyde 3-phosphate that you see down here is then used to make glucose, fatty acids, or glycerol. It takes 2 molecules of glyceraldehyde 3-phosphate to make 1 molecule of glucose phosphate. So the Calvin cycle has to run 6 times to produce 1 molecule of glucose. So it would have to run 6 more times to create 1 molecule of glucose. Now the remaining molecules of G3P, which will be 5 more, we're going to come right here. They're used to regenerate, which is our last phase. Alright, 3 ATP molecules are used in the regeneration stage. And 2 phosphates come off of this as well. Alright. Now whenever this regenerated, this molecule is going to then go back to its beginning form right here, which is ribulose bisphosphate, which is a 6-carbon molecule. You're going to have 3 of them. So that's the Calvin cycle, and this is complete. This is going to complete the Calvin cycle, and this is it.